So, we're doing this analog clock problem. The key with the analog clock problem, let me just demonstrate, is this is 2x, this is x, and this one, the hour hand goes for 3 hours, and the minute hand
goes like around a lot.
goes for 9 hours.
9 hours?
Right?
Oh yeah?
Because they're calling this right here is point A, and this is point B. Whoops. Okay, so I'm going to back out. Here's the problem. If you want to hit pause and read the problem to see if you believe my assessment of the situation. But I believe it, and I'm ready to go. We want to calculate ratios of distances traveled.
Okay.
Okay? And specifically, we want to calculate the distance of B to the distance of A.
Okay.
All right? The best way, I think, to think about this is we want the circumference times the number of laps. In both cases. So for B, the radius is x. The time is 3 hours. So if the radius is x, the circumference is 2 pi x. Okay? Everything I've done so far is easy. The only hard part, how far does the hour hand go in 3 hours? How many laps does the hour hand make in 3 hours?
How many laps? 3. Alright, just not even.
3 out of 12.
3 out of 12.
Right, so it just it goes like from here, like 12, 1, 2, 3, right? It does that deal. Okay, so the number of laps is actually 1/4, not even a whole lap.
Sad.
Okay, so in this case, C times the number of laps is 2 pi x times 1/4, which simplifies down to pi over 2 x. All right, time for A. What's the circumference for A? What's the radius for A?
The radius for A is 2x.
2x. Circumference then is 4 pi x. Easy.
4x pi.
Time is 9 hours. Number of laps is...
Number of laps?
It's the minute
9.
hand. 9, right. Okay. So...
Wait, if it travels 9 hours, it's going to make more than 9 laps.
Just the minute hand.
Yeah.
Forget about the hour hand. It's exactly 9 laps. It's 1 lap per hour. That's what the minute hand tracks.
Yeah.
Okay?
I was thinking second hand.
All right, okay, good. C times the number is 36 pi x.
Okay.
All right? And then finally, the fraction that we make is pi over 2x over 36 pi x. That's the same as pi x over 2 times 1 over 36 pi x. Zoop. Zoop. 1 over 72. Notice at the end there that the x's cancel.
Yeah.
So I could have had x equal to 1.
Or 2.
Right, or any number. So that's what I was saying about when they ask for a ratio, you can just pick a number.
Okay.
Because in the end, whatever number you pick cancels. You see what I mean? I mean, for the most part, 99% of the time. Anyway, but it's no big deal to keep track of the x. All right, so you're good on this one, I think. This is
So the answer is 172.
1 over 72.
Okay.
Right? And this goes back to, remember when we talked about sectors of a circle and the area and the circumference? That's really what this problem is asking, right? Except for it's telling you the sector of the circle, not in terms of the angle, but in terms of like minutes on a clock. Okay, just for future reference, the hour hand travels 30 degrees per hour, right? Because 12 of those would be 360. And the minute hand, how many degrees per minute?
How many degrees per minute? One. What half?
How many degrees per hour does the minute hand? So I'm writing the hour hand while I'm
360.
waiting for you. Right, 360 degrees per hour, which is how many degrees per minute? 6 degrees per minute. Okay? So this is just like someday you're going to have another clock problem. So just remember, hour hand is 30 degrees an hour, minute hand is 360 degrees per hour.
Okay.
And then you can convert that, right? So I did half a degree per minute because 30 over 60.
Okay.
Right. Okay.